Okay, so in this video, this is our second video for day 9 of Unit 4 in geometry. In this video, I'm just going to motivate basically what is volume, right? So I'll give you a second to read this little activity we have aimed at answering this first essential question. I'll give you a second to go ahead and read through and try to attempt on your own. Okay, so go ahead and pause the screen, read, try to attempt it on your own, and we'll go ahead and come back. So all we're really doing, right, is matching how many of these guys it takes to build this guy, right? So the large figure, they're both rectangular prisms. This is a cube, okay? This is a cube, and I guess I should specify that here. I'll probably do that in the actual lesson. I think I was supposed to do that last year and just forgot. But anyway, this is obviously a cube if you didn't figure that out. Okay, and your goal is to figure out how many of those cubes fits into here. Well, here we can see it plain as day. We would have 6 going across, 3 going up, 8 going back, right? So that means we would have 3 stacks, 6 wide, right? So that would be 18 times another 8, right? And I'm having a brain fart now. 3 times 6, so 48 times 3, 120 plus 24, 144. So that would be 144 1 meter cubes, we'll say, right? Or also known as 144 cubic meters, right? So that's how many cubic meters it would take to build this rectangular prism, this box that we see here, right? So real fast, I want to walk us back over everything that we've learned so far. That being, we learned distance, one dimension, right? Whether one or two, we'll say 1 or 2 dimensional distance. Either way, it's linear. All we're trying to see is how many units, how many linear units does it take to go from here to here, right? In other words, how many linear units does it take to make the line going from A to B? Okay, so that's 1 or 2D distance, right? And that is still, no matter how you look at it, even if we, change the angle that this line is presented at to where it's in more than one dimension, right? It's still a linear, measure of simply how many lines does it take to go from point A to point B, right? So now we talk about 2D, right? Whether that's, a rectangle or even a triangle, it's how many square units does it take to build either of these guys, right? So how many square units, U by U, does it take to build this rectangular prism and ultimately also this triangle, right? Which we already know a triangle is half of a parallelogram. So we would just do base times height divided by 2, right? So we're measuring how many squares it takes to build something, right? Previously in 1D, we were measuring how many lines does it take to go from one place to another. Okay, now we're in 3D, right? And we're trying to see not how many lines, not how many squares, but how many cubes does it take to build some solid, some polyhedron, right? So that does it for this video. That's really all there is for volume. It's that simple. Like I said, it's a baby step forward from what we've already been doing in 1 and 2 dimensional measure. If you have any questions over volume, obviously come and find me. You know where to find me, or shoot me an email. Goodbye.